Alrighty, so let's do another one of these ones where it has an elevation, but now they say they being me, I guess, right? Uh, give the ball the velocity and the position vector components on the way down, right? How are we going to deal with that? Well, what we're going to do is we'll just do the same thing we did before, only we'll choose the minus, right? The negative value here, right? So again, we're halfway through a problem. We know that this is 17.603, right? We know this is 25 point, let's see, hold on, what is it? 25.517, right? And now we've got this is my dog. We've got this thing is being launched like this, right? It's going to go up like that, right? And we're looking at it right here, right? So it's on its way down. We're gonna get a velocity like that, right? Okay, so let's see. What do we know here? We know these guys are true, right? We know R, S, T, L, and E, right? 9.81. Does anybody get that reference? I'm just gonna let you puzzle that one out. Okay, so we know that, right? And then 30 meters, we know this, right? And then in a sec here, I'll show you how we like specify down, okay? It's not that hard. We're gonna find this V using this guy. Okay, so V is the square root of, look how straight that is, 25, and then we're doing a vertical calculation here, right? So 25.517 squared, right? Plus 2 times negative 9.81 times 30.0, apparently, right? Okay, so when I do that, second square root, left parenthesis, 25.517 squared plus 2 times negative 9.81 times 30. I get 7.90907, right? Okay, and I'm going to toss that in here, right? Only now we're talking about it's going down, right? The absolute value of this, right, is 7.907. So it could be plus that or it could be minus that, right? I think the vertical velocity on the way down is negative, right? So I'm going to choose minus 7.91 meters per second, okay? Okay, now our final horizontal velocity is the same as the initial, right? 17.6 meters per second. All we really need to do now is to find the time, right? So let's do that. Okay, so I'm going to use on the vertical side, V equals U plus AT. So negative 7.907 equals positive 25.517 plus negative 9.81 times t. Now, if you see mathematically what's going to happen here is we'll put this guy on this side. And last time we did this in the the part before this, right? This was positive because it was on the way up, and that was a smaller number. Now it's going to be a bigger number because it's going to be negative plus a negative, and we'll get a longer time. Okay. Okay, so let's do this. Let's go. Okay, so we'll go that guy plus alpha b divided by, I'm actually using values stored in my calculator, so if you get a slightly different value, that's okay. Okay, so I'm getting 3.407 meters, right? It's actually got a 2 after it, okay? I'm sorry, that's not meters, it's seconds. Okay, so it's longer, right? From here it was at 1.75 or something like that. Here it's at it's 3.407 seconds, right? That goes across 3.407. Now we use this to calculate our displacement, right? And this is a horizontal calculation, right? S is UT. So it's 17.603 times 3.4072 if we care, right? So that times, I get 59.977. So that's 60.0 meters That's kind of fun, right? Okay, so here is our position. It says, what is the position and the velocity of the ball, right? So here's our position, right? Our position is 60.0 meters in the x direction, right? Plus 30.0 meters in the y direction. Okay, the velocity is these guys here. Okay, so here's our position, here's our velocity, right? That's 17.6 meters per second in the x direction, plus negative 7.91 meters per second in the y direction. So many things to mess up. Make sure you do the x first, the y a second. If the component's negative, say plus and negative, y hat, x hat, all that stuff, right? It's not that hard, but picayune, little details, right? If you had to draw this vector, because that's the other thing that these things ask, it would look like this, right? It'd be over a lot, down about half as much, right? Right, this would be the vector right there. You could find that angle there, you could find that magnitude. That's not so bad, is it?